Hello, this video is about sketching quadratics. In the previous lesson we had a look at how to plot or to draw quadratic curves. So we had an expression like this one. We had x squared minus 4x plus 3. We produced a table of values. So we looked at our x values, in this case running from -1 up to 5. Pick one like 1, substitute that into my expression. So if x is 1, I've got 1 squared. Take away 4 lots of 1, so that's -3, plus 3 gives me 0. So when x is 1, y is equal to 0. I can fill in the values in my table, and then I can plot my coordinate pairs. So if x is -1, y is 8. X is -1, y is 8. Mark it on my diagram. X is 0, y is equal to 3, and so on. I can plot my points, and I can connect them up with a smooth curve. This one's not perfect, but it's not too bad. Remember, we're trying to get line of symmetry, so it needs to look symmetrical. We're trying to find that beautiful U shape, and it needs to go through each of the points. Well, what happens if instead of drawing an accurate diagram of my curve, if I just wanted to sketch it? So what I want to do is I want to just pick up the key features of my quadratic curve. What are those? Well, first of all, I have got the U shape. So am I dealing with a U shape, or am I dealing with an inverted U or an N? It's going to have a maximum value, so it doesn't look like that. I need to make sure that it still looks symmetrical once I've sketched it. And I'm really interested, in this case, in 3 points. I'm interested in this point here, where my curve is crossing my y-axis, and I'm also interested in the 2 points where the curve crosses my x-axis, so at x equals 1 and at x equals 3. Those 3 points I need to make sure I've marked on my sketch. I'm going to do that now. So I've got points round about here at 3, there's one here at 1, and there's another point over here at 3. I'm not measuring, I've got no scale along my x and my y axis. I'm not measuring anything, I'm not plotting them in the right place, I'm just putting them in roughly the right place on my graph. So if I've got two numbers 1 and 3, I certainly need to make sure that the 3 is to the right of the 1, and I'd quite like it to be about 3 times the distance of that, but it doesn't need to be accurate. It just needs to be rough. If I was plotting 1 and 20, I wouldn't want to put 1 here and 20 right next to it. I want to be putting 1 over here and 20 quite a bit further along, just to show the relative distance. It hasn't got to be accurate. So I've got my 3 points where it crosses my y-axis, 2 points where it crosses my x-axis, and I want to join them up with my smooth curve. So it's going to come through, round, and up. That one doesn't look too bad. I can just about get away with that one, I think. So remember, we're looking for that U-shaped curve. The line itself should be getting gradually steeper. Make sure it doesn't curve back on itself, so it goes steeper, but it never comes back in on itself. And it should look symmetrical around, in this case, x equals 2. So this one's not too bad, and that's a perfectly adequate sketch. What I would do is I would normally put coordinates on, so I put on the coordinates 3, 0 and 1, 0, and this was the point 0, 3. Okay, so the next question is, if instead of drawing it first, could I sketch the graph of the quadratic just by looking at the equation itself? The answer is yes, I can. So first of all, I've got nothing in front of my x squared, so I've got the equivalent of 1 lot of x squared. I've got a positive number of x squareds. That means I'm going to be dealing with a U shape rather than N. So it's not going to be an inverted U, it's going to look like a U. Secondly, if I try and work out what that point here is, well, I'm looking for the value where these are my positive values of x, negative values of x over here. This is when x is equal to 0, so my y-axis, x equals 0. So if I substitute x equals 0 into my equation, I should be able to work out my value of y. Let's see what happens. So if x is equal to 0, I've got y is equal to x squared, so 0 squared, that's 0, minus 4 lots of 0, minus another 0, plus 3. So 0 minus 3, 0 plus 3, and that's equal to 3. Well, that's the value that we plotted from our diagram. So x is equal to 0, y is equal to 3. These 2 points down here, this time they're going to be when my value of y is equal to 0. So my positive y, negative y, y is equal to 0. So if we write y equals 0 and substitute that into my equation, what do we get? We get 0 is equal to x squared minus 4x plus 3. This is going to be trickier than finding my y-intercept. But what I'm doing is I'm solving a quadratic equation. X squared minus 4x plus 3 is equal to 0. And we've had quite a bit of practice at solving quadratics. We've got our 3 methods. We can either factorise, we can use a quadratic formula, or if we're feeling brave, we can use completing the square. My go-to method is always going to be to try and factorise, and I reckon I can factorise this relatively easily. I'm going to end up with x minus 1 minus 3. Remember, if you need to get a bit more practice, you need to remind yourself how to factorise. Have a look at Miss Begg's video, it's really good. It will remind you how to do that. Looking for 2 numbers that will multiply together to give me plus 3, and that will add together to give me negative 4. So negative 1 and negative 3, multiply to give me plus 3, add together to give me negative 4. Well, if this thing on the right is equal to 0, then either this bit's 0 or this bit's 0. So either x minus 1 is equal to 0, in which case x equals 1, or x is 1 and y is 0, x is 1 and y is 0. So that's that point here. Or the other bracket's equal to 0, so x minus 3 is equal to 0, and x equals 3. So x is 3, y is 0, x is 3, y is 0, and that's my point over here. So we can work out the value of the y-intercept by putting x equal to 0. That gives us the 0 and the 3. And we can work out the other 2 points by solving the quadratic and working out the roots. Remember what happens when I get my factors. I've got an x minus 1 is a factor, my quadratic here, but I end up with an x equals positive 1. So x minus 1 equals 0, x equals positive 1 for my roots. So x is 1, x is 3, 1 and 3, my 2 x-intercepts. Let's have a look at another example. So this one we haven't drawn first, so we've got no hints. We're just going to have to use our techniques to try and work out what we're doing. First of all, I've got one lot of x squared, so I know I'm going to be dealing with a U-shaped rather than an inverted U or an N. I can have a look at what happens when... let's start off with x equals 0. X is equal to 0. What do we get? X is 0, y is equal to 0 squared. It's 2 lots of 0 minus 3. So we've got y equals negative 3. So x is 0, y is negative 3. So this time my intercept is below my x-axis. It's going through that point. My curve is going through that point there. And then I want to have a look at my x-intercepts. I'm going to put y equal to 0. What do we get? We get x squared plus 2x minus 3 is equal to 0. Again, I'm going to try and factorise this. I reckon this one's going to be not too bad. I've got a negative sign at the end, so now I'm going to end up with 1 positive and 1 negative. A positive sign here, so I'm looking for more. So my factors of 3 are going to be 3 and 1, positive 2. I reckon I'm going to be looking for plus 3 and negative 1. Let's double check. So 3 and negative 1, product. 3 times negative 1 is my negative 3. Add them together, plus 3. Take away 1 is plus 2. So correct factorisation. I can then work out what my roots are. So either x plus 3 is equal to 0, which means that x is going to be equal to negative 3 if I subtract 3 from both sides. X equals negative 3. Oh, that point's going to be over here somewhere. That was also negative 3. Or my second bracket is going to be equal to 0. So x minus 1 is going to equal 0. If I add 1 to both sides of my equation, plus 1, I'm going to get x equals 1. So again, it doesn't matter. I'm not measuring, I haven't got a scale, I'm not measuring where to put those points along the axis, but I do want to make sure that this one is closer to the axis than my negative 3. Also means if I've got these 2 points, remember my line of symmetry needs to be halfway between the two. I need to make sure that line of symmetry is to the left of my y-axis. It's going to be, so halfway between negative 3 and 1 is here at negative 1. So I need to make sure that my curve, when I draw my minimum, it's got to be on that left hand side of my axis. So let's have a pencil and give it a go. So it's coming through here. It's going to start to rise again and then come up. Again, I'm not too disappointed with that curve. It's a little bit wobbly at the end, but I've got the rough shape. So I've got my U shape. It looks relatively symmetrical around my x equals negative 1, so not too bad. Again, with this, I'm going to make sure I could probably get away with putting my intercept points on, but much better to write in coordinates if you can. So we've got 1 and 0, we've got negative 3 and 0, and the point down here is at 0, negative 3. So I've got my curve, I've got my U shape, I've got my 2 x-intercepts, and I've got my y-intercept marked on my diagram, and I've sketched the quadratic. The reason for having a look at this, it really pulls together the work we've done both on drawing the quadratics, but also the work that we did on factorising and solving the quadratics. The reason we do that is so that we can sketch these graphs and we can learn how they work. I'm going to have a look at one final example. This one's a little bit trickier. What we've got now is a negative sign in front of my x squared plus 2x plus 8. But we can go through the same process. First of all, that negative sign means that I'm not dealing with a U, I'm going to be looking with an inverted U or an N shape. Not a U, it's going to be this one over here. I can start off again by putting x equals 0 and substituting it into my expression and see what happens. So if x is equal to 0, y is equal to negative 0 squared, well that's still 0, 2 lots of 0 plus 8. So 0 plus 0 is 8. Let's mark that on the diagram up here. Again, just like when we had our straight line graphs, this number on the end of my x squared and x expressions is always going to give me my y-intercept. So plus 8, the graph is going to go through 0, 8. This time, let's have a look at the x-intercept. So if y is equal to 0, what do we get? We get minus x squared plus 2x plus 8 is equal to 0. I could try and factorise this. That negative sign in front of the x squared makes things much more difficult. You're much more likely to make a mistake. It's better to, for a first step, multiply both sides of your equation by negative 1. What would that give me? So it will give me positive x squared minus 2x minus 8 is equal to 0. Now I've got this positive x squared in here, it's going to be much easier to factorise. So I've got x equal to 0. I know I'm going to have x's here. I've got a negative sign on the end, so I'm going to be looking for one positive and one negative value. I've got a negative 2, So my negative is going to be big